Number five, summation as n goes from 0 to infinity, n squared plus 2 to the n over n cubed plus 3 to the n. Okay, so this does not look super familiar even to me, okay? Someone with more experience solving these. So let's go down our list maybe, okay? We have the test for divergence, which we could try in a bit. Let's keep that in the back of our mind for now. Do you want to do the integral test? This integral looks super nasty to evaluate. I don't want to attempt it. So let's try to avoid that if possible. It's not alternating series, so we can't use the alternating series test. Okay. What else do we have? The ratio test doesn't look like it would work nicely here. It might be doable, but the algebra won't be super nice. Okay. It works, the ratio test works for when you have like things multiplied to each other, which is not the case here. There's like additions here, so it'll make it not that nice, even though there is an exponential here. Okay. Not the root test because it's not the whole series to n power, right? Am I missing anything else? Oh, comparison test. We could always probably compare it with something, but let's try to keep that as a last resort. Okay, if you're lost as to which technique to possibly use, I have a whole video going over tips and tricks of how I usually think of the problems. You can go check that out. All right. It's on my channel somewhere. If I remember, I'll link it. Okay. But let's first use the test for divergence. If the limit is not 0, then we're done. If it is, then we have to try something else, okay? Unfortunately, if we actually write it out, I guess I didn't here, the limit as n goes to infinity of this guy is 0. Let's have some intuition now that, even though I didn't write it out. This 3 to the n will probably dominate as n keeps getting bigger, okay? Which means the bottom will get bigger, bigger the quickest, or biggest, or whatever the right terminology is, so then go to 0, okay? If you actually find the limit, you'll see that it's 0, okay? So now we're stuck with our last resorts, the integral test and the comparison test, right? I guess we also said the ratio test might be doable, but we're trying to avoid that. So let's try a comparison test. What can we compare it with? Okay. So let's try to rewrite this series as these two right here. I just broke up the fraction, okay? And then we can go one by one. If both of them converge, then of course this got converged, right? This equivalent representation. If even just one of the pieces diverge, then it's likely the whole thing diverges because it's not like we're going to have a negative infinity and a positive infinity or something like that. Then that's infinity minus infinity, that's indeterminate. But it doesn't look like we have that here, okay? It's going to always be positive. Okay, so let's try the first one first, okay? So this over here, let's compare it with n squared over 3 to the n. We know that this guy on the right-hand side is bigger because we're dividing by less. Over here, we're dividing by more. Okay? So let's compare, let's do this comparison. Okay? This guy, we can use the ratio test. Okay? So if we do that, I won't go through all the steps here. It's 1/3. The limit is 1/3. What does the ratio test say? If it's less than 1, that's limit is less than 1, it converges. So this guy converges. And therefore, since this guy converges over here, and our guy is even smaller, it must converge as well by direct comparison test. Okay? Now let's go through the other piece now. What can we compare it with? Well, we can say that this guy is less than 2 to the n over 3 to the n, which we write as 2/3 to the n power. Why is that again? Well, we're dividing by more on the left-hand side here, okay? How about this series? Does this converge or does this diverge? It converges, right? Because it's a geometric series with r equals 2/3, and that's less than 1. So it converges. So since the two pieces converge, the original series converges as a result. Okay? This is one way to do it. I'm sure there's lots of other ways that you can approach this. This is how I approached it, though. So if you did approach it a different way, please feel free to leave it in a comment. Like even if you just compared it with something else, feel free to leave it so that leave the comment so that other people can learn as well. If you did the ratio test, leave a comment as well so that we know that it actually works as well. All right. Hopefully this was helpful. Hopefully I'll see you in the next video as well. Bye.